Hey, welcome back to your Cloud Strategist channel. Today, we're going to look at modern data platform reference architecture and some of the terminologies related to that. This fits in all the solutions that customers build today to solve their data analytics problems. In earlier videos, we looked at the increasing importance of data and collection of large volume of data to solve large-scale problems, global pandemic scenarios, for example. And also we looked at the increasing importance of moving data to the cloud in order to keep it as close as possible to ubiquitous computing and highly available computing. So let's recap on why we move data to the cloud. So the first reason being simple scenarios like you want to get rid of your data backup on-prem. You want to get rid of your tape backups and put them on the cloud for long-term retention. Also scenarios involving scalable, secure, and cheaper storage. As a second step, we are looking at customers who move data for analytics and reporting purposes. And only advanced customers look at using some of these data for machine learning and artificial intelligence. The second option that you see there is essentially covering analytics on history data as well as the current data. But the third point covers something around predicting future data. And that's where machine learning comes into picture. There are other reasons why organizations move data to the cloud. It could be part of their enterprise cloud strategy, their compliance requirements, their geographic distribution, and application modernization and visualization. Now, having moved to the cloud, how do you deal with that data? How do you make the best out of that data? So that's where the reference architecture comes in handy. So this diagram is something that I use at least with 90% of my customer conversations. And if you look at this, it actually has solutions for different types of data platform scenarios. So let's look at this diagram in detail. On the extreme left, you're looking at data that comes in different varieties, and if it's grouped together, it falls under these 4 buckets here. On the bottom left, you're looking at a structured data type. These are traditional relational databases like SQL, Oracle, your BizApps backends. This is considered strongly typed because the schema of the database is pretty rigid. If you have to make changes, you have to make a whole lot of changes in the application layer. So it reduces the flexibility in expanding your database structure and the application model. On the contrary, the semi-structured data types that you see here, like CSV, log files, and JSON and XML files, these are loosely typed because their schema can be easily modified and your application does not need much of a change. More than 90% of the data types which are contributing to the humongous growth of data is all coming from semi-structured and non-structured data types. So the third type is that non-structured or unstructured data type. As you can see, it's that V which gives variety, and you see a whole lot of different types of files, including images, videos, audios, and free text. This doesn't have a specific structure. The file itself is your data. The image itself is your data. The video itself is your data. So these are considered unstructured. And the final type is the high velocity data. These are typically information coming off your social media feeds, IoT devices sending telemetry information into the repository, and it could be other gadgets like health bands that you might be wearing. So any of these data that flows in real time is considered to have very high velocity. These data are highly sensitive, time sensitive, because we need to be acting on this data in real time. And that's where you see lot more real-time processing engines which analyzes these type of data. So once you have identified the data types, these becomes the source for you. And the next step is to ideally ingest this data into the cloud. And traditional legacy way is to just copy your content from one FTP repository and move it to a file share. So these has been legacy ways of how you move data across. But imagine you want to move large volume of data into the cloud. So one of the important entry point is this the ingestion solution, which is the Azure Data Factory. Azure Data Factory is a pipeline management ingestion platform as a service. So essentially you can connect to 99 plus different types of source data and actually create a pipeline to copy those data into the downstream services, or you could copy the data into a database on the other side. So if you have used SSIS packages back in on-prem, which is the SQL Server Integration Service, this is very similar to that, but with a lot more capability and capacity. Because it's a PaaS model, you can burst the resources in real time. You can expand them. You can and then you can scale down very easily as well. So the data factory is an important entry point for batch processing. So the reason I call it batch processing is because anything under this layer is considered a kind of a cold path or a batch processing layer. So these are traditionally the existing data and the current data that needs to be moved into the cloud. In contrary to the hot path where the data velocity is very high and they have to be moved in very quickly. So once you have the data factory connect to the source and start ingesting the data into the destination, and the destinations could be anything like a data lake, could be a SQL database, could be a file repository, could be a blob storage, and anything. So once the data comes in and into your choice of the destination, in this case I'm talking about Azure Data Lake Gen 2, which is a file system on top of the blob storage type. Now essentially the file system gives you hierarchical namespace, which means you can deal with data much better when it comes to analytics requirement. But functionally it's similar to a blob storage, but with a lot more secure and easy way to access the data that sits on top of that. Now, why do you need to move the data to a data lake? So consider this as a repository that can have a heterogeneous data types. Now that's the point where you might want to stage your data and process them or pre-process them or transform them before you would load into your permanent storage or long-term storage like your typical data warehouse. So that's a point where you make transformations, you make modifications of the data, and you can of course run analysis on top of that data that sits in the data lake itself. Is that a mandatory staging point? I would think yes, if we consider a very long-term solution where you want to bring in varieties of data and deal with them. I think that's a pretty good staging and it's good to have a strategy around that. So once that data is processed, and that's where you start shifting your structured data. So what happens is with that heterogeneous data type, you want to convert them into a structured form so that they can be analyzed in a sensible manner. So once that's done, the data is copied over to your data warehouse. So in this case, Azure Synapse Analytics is a data warehouse. So if you have used SQL data warehouse, it's very similar to that, but with a enormous amount of additional features and capabilities that have come into that. Think of this as a massively parallel processing engine that can deal with terabytes and petabytes of data in no time. And it comes in two different flavors or two different ways by which you can use them. One is a serverless model and the other one is a dedicated resource model. So the serverless model is typically useful when you have ad hoc data coming in, when you have burst of data coming in, or you might have a pipeline that is going to ingest data maybe just once or twice in a day. So in that case, it makes sense not to dedicate resource and rather use the serverless. The serverless also can operate, and it operates directly from the data in the data lake. It does not move the data into a database form similar to the traditional SQL databases, but instead it operates purely on memory or in memory. So what it does is it imports the data through Polybase, and that's the most efficient way of moving files like Parquet files into your Synapse environment. So the way it treats the data is as an external file or external table. So the data still sits in the data lake or the blob storage, and the external tables project itself in the form of a table within the Synapse environment. The other option is the dedicated resource, which is very similar to your SQL data warehouse. So depending on your requirement, you can choose one or the other. Obviously, the serverless is a lot more economical as compared to having a dedicated resource. So just to look at a little bit more on Synapse. So Synapse has got two types of analytics runtimes. So the one is the Apache Spark based engine or cluster on which you could run your traditional Jupyter based notebooks and do some analysis or analytics on top of your data. It also has the SQL engine, and if you are familiar with T-SQL and SQL in your organization, then you would continue to use the typical SQL way of analyzing your data. So as you can see, the underlying storage structure is still the data lake, as we have seen in the other diagram. Synapse is a lot more, as I mentioned. It also has a capability of Data Factory built in within Synapse. So if your architecture does not need a separate Data Factory for other reasons, you could directly use the data integration capability, which is exactly like the ADF functionality, which is built in within the Azure Synapse Studio. So it's kind of a unified experience of how you run data integration and then bring it to your environment for analytics by connecting all the data that sits in the data lake Gen 2. The Synapse as a product also natively integrates into Azure Purview, which is a governance tool that's been announced. It's an upgrade or version 2 of data catalog that existed before. Synapse also connects natively with Azure Machine Learning. So if you have a machine learning model, you can invoke the model directly as part of your T-SQL query and actually subject your data to go through that machine learning model and get output from there. So in some sense, I would think it's kind of a nucleus rather than just a Synapse, because it conduits in different types of data sources. We think Azure Synapse makes great sense, and it's a great tool to think of and strategize. So once the data comes into the data warehouse, so this starts serving as the service layer for your enterprise data model. So essentially that data that sits in the data warehouse, using which you can build the enterprise semantic model, which can serve as the visualization layer for your organization through Power BI. So Power BI is a visualization tool similar to how some might use Tableau or other solutions, but Power BI is a lot more powerful because it allows you to build this model. If not, you might have to use analysis service for building multidimensional cubes for your reporting. So Power BI comes with all those capabilities built in as well. Now, we have seen how the data flows gets ingested into the environment. So that's the extraction part of ETL that we have spoken about. And the next step is your transformation. So that happens in the data lake. Data Factory also has a lot of transformational capabilities, things like creating aggregated columns, and then finding an average or some of your data within the table structure. So all of that is possible using something called a data flow within the Data Factory. So we will look at more detail on some of these specific products in other videos, but essentially your data flows through Data Factory, gets ingested, gets transformed, and then finally gets loaded. So that's your loading portion in the ETL process. And the data warehouse serves as the serving layer for your visualization and analytics result. Now, similar to how Synapse works, Databricks is also a parallel processing engine. Now, the reason we treat this as a first citizen offering on top of Azure is because Databricks has been optimized to run on Azure, and the support model is well integrated. So if you are an existing organization where you are used to Azure or Databricks, then you can use Azure Databricks, which is kind of a one-to-one, easy to use, because you carry forward your existing knowledge on Databricks. So this works in similar model in helping to transform large volume of data. So you run your notebooks and transform data and use it for loading it into your data warehouse eventually, or back into your data lake, and that's why you see the two-way arrow up there. So that's Azure Databricks. Now the Databricks can also serve as a compute engine for machine learning models that one might develop. Now, cognitive services are pre-built machine learning models that Microsoft has built, and it's exposed through APIs. So which means you can subject your data through these pre-built models and get the output very easily. So it covers things like image processing, text analytics, video analytics, and search, and a lot more. But if you want to build a custom machine learning model, that's where you use Azure ML. And again, the Azure ML uses these compute layer, has its own compute as well. So, but you can run large clusters using integration through Azure Databricks. So that's at a point where you want to do predictive analytics on your data. So it's kind of a future state that you want to look at, and whatever you do as part of the analytics on this side falls under the category of existing data and the history data that you want to analyze. So once that's been done, all of these data gets into the serving layer, which is your Power BI dashboard, or it could get into your application backend, which is Azure Cosmos DB in this case. Now, depending on your application backend, it could be a SQL server, for example. The reason I want to highlight Cosmos DB is because Cosmos DB is a multimodal database. So if you have an application that needs graph type data, and at the same time maybe documents that you might want to store, and also maybe a relational table structure that you have. In legacy models, what you would ideally do is to run each of those in different databases because they are of different data types. But in this case, Cosmos DB can run all of those data types within the same platform. And it exposes connectivity through APIs that allows the application to connect back into this backend. Now, if you have run traditionally using some of these example database types like Gremlin for your graph, for MongoDB for your document type of library, and if you've been using Cassandra for columnar storage, and maybe Azure Table Store for your key value pair, all of these data type can natively get into Cosmos DB, and these are the exposed APIs. So that means your application that you have built, which talks back to your Gremlin, can just use the same API and connect back into your Cosmos DB data environment. Now, why Cosmos DB? Cosmos DB is meant for large scale or global scale applications that run in different parts of the geography. So it helps in replicating data at a very high velocity across the globe. So we're talking about milliseconds for a replication across the globe. And it provides, interestingly, it provides 5 different consistency model. When the data replicates from one point to the other, you can determine what type of consistency you need for your application. It could be a strong consistency, or it could be an eventual consistency. So what it means is the data gets replicated, and only when the replication is complete, it's available to your application. That means you need to make sure it's highly available and the data replicates very fast in the case of a strong consistency. Eventual consistency is sometimes when your application is accessing this replica, probably it can look at an older version of the data, or probably it's not the updated version. And everything in between is a gradient from all the way from left to right, with a different balance around consistency and availability, right? And that's where you're seeing it's weaker consistency towards the right, and it's a stronger consistency. So Cosmos DB is a solution for very large scale applications running across the globe, or in multiple geographies. And of course, you can leverage on the capability of having multiple data types within the same platform, so you're not running different. It's again a PaaS-based services, easy to handle and deploy and manage, and readily integrates with the rest of the components within Azure. Right. We have looked at how the different components fit together from an analytics perspective. And is this a composition of all the components available within Azure? No. So all I have highlighted here is the core components that helps us to understand the process of ETL, and at the same time that you can achieve at a very large scale when you have to deal with a large volume of data. There are other components that may or may not be shown here, and there are other ways by which you can achieve the same solution, but some of these are strategic long-term platform components that you might want to plan right away, right? So this architecture as a reference can serve for simple solutions. For example, it's about copying your data into the cloud. So that's our option 1 that we have seen in the slide deck. So for example, I'm moving everything back to a data lake, or yet another storage component. Now the second option could be to extend this for analysis, and which covers history data as well as the current data. So you might use any of these components, including Databricks, and then maybe use Synapse Analytics if need be, and then get your data for analysis purpose. So that's another option. That's our second reason to move to the cloud. And the third one, of course, includes data that moves into the cloud, but not just for data warehouse and analytics purpose, but also for your predictive analysis of the data. So that rounds off pretty well for large enterprises and organizations who want to have a pretty good strategy around data analytics, and use it for enterprise dashboards, visualization, application backend, and application data that needs to be enriched with things like machine learning and artificial intelligence. So I hope it gives you a clear idea on how these different components work together and what is the purpose of each of these components. I know it's a long video, but I'm sure each one of you would have something to take back. I'll talk to you again in one another interesting video. Till then, take care.